Oh, yeah, I could put some in real quick, though.
All right. How's everyone enjoying their pancakes? Who had pancakes today? Awesome. 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 Hi, I'm Alex Williams. I'm founder and editor-in-chief of the new Stack, and we've been doing these pancake breakfasts at these different events, and well, I just love pancakes, so I'm happy to serve pancakes whenever I can. The new Stack is a blog site, really, that discusses application development and management at scale. And we focus on the analysis and explanation of these technologies more than anything. And so I actually have had the privilege today to be able to be with this group here, and we're going to talk a lot about how distributed systems apply to this new world of the Internet of Things. And I was actually having a conversation just beforehand with John Moore from Comcast, and he was calling the Internet of Things actually a distributed system in itself, which I think is a concept that I think really makes sense. And the one thing that intrigues me about the Internet of Things is how everything becomes a data object. And so you start to ask yourself, well, is that really a chair over there? Or is that a data object? Is that a table over there? And I think it goes back to what you were saying about this proxy, right? Well, is the data object a proxy to the table, right? Or is the data object, are we the data objects ourselves, and how are we all connected in many different kinds of ways? So this discussion is really meant to try to explore some of these topics, and I'm really interested in how the technologies we're talking about today, this programmable infrastructure that we're talking about, applies to the Internet of Things, and what are we seeing today that does actually apply, and what does not. So maybe the first thing I'd like to do is just have everyone introduce themselves. And so Nick, why don't you get started there?
I'm Nick. I just talked.
I'm Dave. I talked before him.
I'm Duncan. I'm just about to talk. The first thing I'd like to do, though, is wish Alex a happy birthday. So happy birthday.
Hey, thanks. I appreciate that.
All right. I'm Donnie. I'm the analyst that Nick was making fun of.
And I'm Mac. I'm from IBM. I'm the old guy.
Great.
I think we've got all our stereotypes here.
Well, good. Well, let's just get started. Maybe on that topic, just to start. I mean, defining distributed infrastructure and what does it mean? Is the Internet of Things really a distributed system in itself? And maybe Dave, you can just get us started on that idea.
Sure. So I do think the Internet of Things is a distributed system. I think that's a fair characterization. I think it has some different properties than what a lot of us would be used to with a traditional, say, high-performance distributed system, or what we would think of as high performance compared to what the Internet of Things is comprised of. I do think that Internet of Things is going to have a large number of challenges, but I think it's going to solve a lot of problems that we've had or that we've thought were impossible to solve. Outfitting, as you aptly put it, objects, Internet of Things based on objects is a chair, an object, or a thing. We think of object-oriented programming and such. Well, this is going to be object-oriented reality.
Right. Object-oriented reality.
I like it.
How about that?
Yeah. Something I wanted to add to that, because I think you just sparked this thought in me. So my old company ran this conference in IoT a couple of years back, and we had James Gosling come in to talk. And he invented Java, obviously, but before that, he invented Oak. And Oak was an IoT language. It was designed for set-top boxes. The thing he was talking about there, though, was super cool because his new company is building these submersibles that go out in the middle of the Pacific Ocean and monitor waves and are kind of self-powered and everything. And thinking about how the IoT is a distributed system made me think this is an extreme example because of the latency and the really poor pipe involved, right? So you can't really do these consensus things. You have to be able to do a lot of independent processing. I mean, the thing he was saying was, so they've got the submersible out there in the ocean taking pictures because it's cheaper than spending $100,000 a day sending a ship out there and back. But the problem is, if they want to send back pictures over a satellite link, it's $1 a kilobyte.
So that's interesting. thought about, the submersibles, it gets to the idea again that everything actually is a node. And what we're already seeing these real complexities with networks right now, with distributed systems, and actually there was a conversation I was having with John too. He was saying, well, just look at the network now. It's like things get mixed up all the time. It's just the way it is. And so Mac, maybe, I'm curious in your perspectives about this kind of, if we're moving into this world of distributed systems as it relates to the Internet of Things, the application and the network and the complexities we have today, what are those complexities that we can expect to see when we actually have just billions of objects connected?
Yeah, so one of the reasons that IBM, I own the networking team and the innovation team, is because when you look at what IoT can provide you in terms of the potential, in terms of the innovation, the network is one of the main things that's in the way. The network was, going back to what Nick was talking about with the client server, it was built and architected according to what the rules were at the time. And the rules have drastically changed now. And so the network has to be much more agile, it has to be much more adaptable. And the network can't do everything on its own. You've got that speed of light thing that Nick also talked about that gets in the way. So the ability to take the data and be able to access it where it needs to be accessed so that you don't have to move it. The ability for the network to cooperate in that kind of distributed data model, I think is really important. And so we're doing a lot in terms of software-defined networking kinds of capabilities, but also just making it such that the network functions are a lot more consumable, and it's just part of the service. It's part of the data fabric, instead of it being a separate thing. Because whenever it's a separate thing, that means somebody else has to take care of it, and then you can't have this kind of spontaneous innovation that's happening at the device layer, at the aggregation layer, or even in the back end, and they can't interact in a way that's conducive to these kinds of very proactive solutions.
Duncan, you're with Cloudsoft, and you guys, really focus on distributed systems. What are your guys' perspectives?
So I would agree with the object-oriented reality comment, but I would say, when you talk about a data object, you think of something, if you're not careful, as being somewhat inert. And I think it's much more about a set of interconnected elements that have sensor-effector interfaces, so you can interact with them, which is why
So how do you interact with them then?
So, well, the sensors would, it's like your idea that, you're on the internet because you've got a smartwatch, so your heartbeat's out there. It's not just about taking that heartbeat, it's about being able to interact and analyze that heartbeat and maybe have a feedback loop where you then affect or change something.
The thing I think about, my brain looks for patterns. I feel like the microservice movement, the idea of taking monolithic services and breaking them up, is almost a shadow of the IoT movement. Because if I have going back to my stupid talk on client server, if I have a workstation, I did everything on the workstation. So the internet was designed for me to go somewhere, right? And it was just between me and that other guy. And the internet was this pipeline of interconnected things that the whole purpose was just to get this to there. And didn't really interact with that, ultimately. In fact, it was not supposed to interact with it as it goes along that route. When someone interacts with it, that's bad, right? With IoT, it's this thing where my house is going to have information, I'll have information, and does it all flood back to one spot, or does it combine? Do we emerge this kind of like bubbles and tiering thing, where like maybe geos or my home, and you get these like levels, and I feel like
it's
the
like
same
the layers of an onion.
It's like microservices, right? Like my application, I could write a service which manages everything about Dave. So the service, but then I write a microservice which one part of it says what shoes will Dave wear, what watch will Dave wear, how does Dave comb his hair today, right?
So
But ultimately, it's still Dave that comes out of it, right?
This is an autonomous system, therefore, right?
Right, totally.
I'm a distributed system. We're just saying take that and scale it out.
I look at it a little differently. I look at it as Internet of Things is about a whole series of different types of feedback loops. And it depends on what needs to be achieved to decide how that feedback loop is going to work. So the feedback loop might be that I simply want to know if I left the oven on in my home. And I can do that all with machines. So I initiate from my mobile device, it goes out, it connects to a cloud service that's getting sensor data that knows that the oven's on, and I'm able to then see a visualization of that on my phone.
But I disagree because...
Well, wait though, so at the same time, it might be that that I need to go out and do some specific activity that requires me to physically do it. And the feedback loop might be that it's me taking the action or me having someone else take an action. So it's the crossing of the boundaries between the digital and the physical that make it such an interesting thing. These feedback loops can cross between the actual and the virtual. And I see that as why, I see that's what makes this so powerful and interesting, and why these distributed systems become so complex, because it may rely on physical things happening. And you might have that autonomous robot going around, but what if the tread breaks or the tire breaks or what have you? Well, now that feedback loop's broken, and how do you go? Does something else go repair that? That's when we get into complex systems or complex microservices. And if you've ever built a really high density number of microservices and you've tried to deal with them being interconnected and dependent on one another, or tried versioning microservices, say you have a dozen microservices and you're revisioning them, try doing that and you start to realize that microservices get really, really complex when dealing with them. Even though each one has its own discrete functionality, it's still really difficult to manage a large number of them that work together.
Duncan?
So I'm so forgetful that I wouldn't actually use a mobile device to check whether I'd left the oven on. I'd actually push that rule down and have that just tick away in the background, because the chances are, 1 in 3 times I will have left it on. So, and if all I had ever thought about was, did I leave the oven on? Did I leave the oven on? I'd be going around worrying about that. Or did I lock the door? So these are examples where you can push that processing out, and that's what I was saying, really.
Sure.
No, I feel the same thing. I think the IoT stuff develops like those concentric circle theory in a way, like or emerges. I don't know what it looks like. I just say you emerge with something where it even inside of the vertical. So let's say health data. So most of us probably work for companies or educational systems. Maybe you sign up for one health plan, and then that health plan, they give you those devices, and it merges all those devices, anonymizes it, and figures out for that company who's like, what's our average health? Well, should that all go up to one server, or should that get coalesced to the one company? And does that one company broker it to another company?
Well,
what does the tiering look like?
And the other piece there is a lot of times people think of the IoT and they just get caught up in being able to handle the number of devices.
Right.
But that's just the connectivity piece. The harder piece is handling the rate and pace at which the data and the amount of the data. And if you look at the traditional data models that were done when you had, the traditional kind of internet client server, they were all consolidated, they were relational, they are kind of vertical scale up in their architectural model. And so if you're trying to handle the rate and pace of the data and the amount of data with those systems, it's a square peg in a round hole.
And that's not even bringing up security. Like information was off
What's that?
like what's security? Yeah. Says the CTO. No, I'm just teasing. But like
That's an old school.
Does
That's an old.
Intel own a security company?
Isn't that an old school term?
I
Security.
think we own like 5. But when something comes off of a device of mine, do I trust the first person that gets it, the second person? And is there relationships where maybe Google runs an infrastructure that another company runs on top of, then another company runs on top of? Like what does that look like from a safety and security? And like, do our protocols match that? Like we've got these protocols that like, it's this guy and this guy, nobody in the middle, but then there's like this guy and then this guy and then that girl and this guy and that girl, right? And like, how do we have security across those boundaries?
Donnie?
Yeah, I think one of the best points that I ever learned about security was that, you can't tack it on after the fact.
No.
You can't say like, all right, we've got the internet, now we'll secure the internet. Like that doesn't work, and we're starting to discover that more and more now as there are sort of core security issues discovered in the protocol itself.
But it's so
you've got to have
but
security by design
but it's so semantic, isn't it? I mean, security, like we talk about it as one thing, but actually, it's
a lot of
encompassing
things,
of
right?
a whole.
But I mean, like, so for example, take Google, right? Until a few years ago, every piece of traffic that went around internally at Google was insecure, and they just said, oh, we're secure at the firewall, we're good there, we'll just have SSL terminate at the end. That'll be fine. And then they got hacked by the Chinese government, and it didn't work out so well because all they had to do was get one endpoint inside listening promiscuously to everything going back and forth, and they had access to everything. Right? But as we move toward microservices, you have to secure traffic between every single one of those services.
Totally, yeah.
Same thing as distributed systems from a database perspective. Every single communication there has to be secure from the start, or the whole system won't be secure.
But Mac, when we talk about these things, for example, like if my sneaker is programmable, right? And I have it connected, to my hat, for example, or my glasses or whatever. and I want to, I want these, these things that I'm wearing to connect with each other, and maybe something with, something else that that it's in part of my sphere, so to speak. That's going to require tremendously open systems, because if you don't, you're not going to be able to have any of these connections whatsoever.
Right. So one of the things that's kind of an interesting dynamic that's happening here is that if you incent the right behavior, people tend to do the right thing, all right? And so if you, me as a data analyst, all right, if I give you an incentive to share that data, and I can give you some kind of terms and conditions of what I'm going to use that data for, how I'm going to use it, how I'm going to secure it, and you become comfortable with it, and because you're sharing the data, I give you some kind of value back. That could be monetary, that could be, you're the top data producer, whatever. It could be just, a star. Who knows? People are driven by all kinds of things. Mm-hmm. But you saw, like, IBM bought the weather company, which was kind of, okay, that's kind of a strange acquisition for IBM to make. But if you look at the weather company, you have the Weather Underground, where you have individuals that they either just love weather and they want to contribute and make the weather forecast better, or they want the recognition, or it's just really cool, their gadget. But there's an incentive for them to participate. That gives more data points to get more value. And so there's this feedback loop. That's the same thing that happens with frequent flyers and everything else. So I think what you're going to see with the Internet of Things is people being willing to share data because they're getting value back.
Right, or being unwilling, right? Because, frequent flyers, for example, every time I go on a flight, I get a survey from Delta or whatever. It says, how'd the flight go? I say, why would I ever waste my time filling this out? You're not giving me anything for it. I never even get a feedback when I fill it out that you received it. Right. Let alone like 200 miles or something that I care about. Right. So the lack of incentives is, just the flip side of the same problem.
Well, we have such a social, it's such a social world that we live in now. People want that kind of interaction. It goes back to what Dave was talking about with that feedback loop. If you can make the feedback loop such that people are incentive to participate, to make things better, that's the real opportunity I think we have with the IoT.
So today, when we talk a lot about distributed systems, and we talk about application development and management, right? And really where we're at today is like, the internet is connected to billions of people, whether they know it or not, right? So that means that we're going to have this continued drive to program the internet, correct? But with the Internet of Things now, we're not just talking about, we're talking about a whole different kind of application, a whole different form of application development and management, which begets then the changes in the data center itself and all these, the systems that we're using today. That's one of the things I'm trying to look at is like, how are the systems that we're using today going to help us get to this new place? You talk about, for instance, like this 3D storage like technology, right? Yeah. And things like that. And you're also drawing on older technologies that you're using, for instance, to kind of enhance, schedulers.
Yeah, from my standpoint, I think we're still having the operational practices emerge in some ways. So we talk about the IoT stuff. The one thing that's cool about IoT devices, they can be anywhere. The thing that sucks about IoT devices is they don't have a whole lot of power, right? And so ultimately, there's still a lot of pressure back on the data center side of things, do a lot of processing and stuff. And so what I'm finding interesting is what are the operational pieces? So how can we make the platforms faster, obviously, but where are the bottlenecks going to emerge? So if you take a pattern like client server and we get really good at making those hotspots fast and you completely flip it over to a new pattern, what does that cause as far as like hotspots? So that's one piece. It's just in the back end data part. But then like the encryption piece, like security, the acceleration for like how do you deploy to these devices, and then just the management piece of it. If there's 50 billion devices in the world, how do you know where they're at and who has them and what how do you keep track of all that, right? Not much less just the inventory piece, but like the connectivity piece. Like pick one of the 50 billion devices and say, tell it where to go connect to. Who tells it? When do they tell them? That kind of stuff. And so for me, for Intel's perspective especially, we don't necessarily, we help try to innovate and lead with some of the patterns, but a lot of times we look for the pattern and say, what are the hotspots? What are the places where we provide value in that? And I think for a lot of that's still being pretty, it's being explored quite a lot. I don't know if there's a lot of answers there yet.
So Dave, I'm thinking, specifically about how we managed, today's databases, right? And we're just seeing the acceptance of of NoSQL, right? And so that maturity model is still developing. What are some of the things that, as a database systems engineer, you're thinking about when you're thinking about connecting all these nodes and all these kind of, systems and that are going to need to have these feedback loops that you talk about?
Well, I think it's really about the speed that's required around that feedback loop and the speed at which you need to process the data. Everyone has a different definition of what real time is. In some people's world, real time is within a matter of hours or minutes, and in other people, it's milliseconds, microseconds, or nanoseconds, depending. So, at least on the database side, you deal with a lot around time, the idea of time, latency, and concurrency, and dealing with Internet of Things problems. How do you deal with aggregating that data and recognizing a pattern or something that you need to take an action on? It turns out that some of those things are fairly difficult problems, especially at real scale. And especially if you need to keep the response time.
Oh, they're not that complicated, come on.
You're right. I'm blowing it way out of proportion.
It's
actually not all that difficult.
All this talk about complexity.
I'll give you a concrete example. I'd be really worried if my pacemaker was being hosted in Amazon US East. I don't care how good Netflix architecture is. I'd much prefer that to be a little closer to home, if you know what I mean.
Yeah, that's because you've only got one phone, right?
But there are some theories that people will say,
cluster.
there are some theories that say that people will just be want to move closer to the data centers, right? Because then we'll start to see communities emerge around the data centers.
Wow. It's almost like gravity.
So just a point on that, what is a data center? I think what is
that
a
is
data
a good
center
question.
is going to completely change. I mean, people, when they talk about data center, they usually think of big brick and mortar, or think of lots of racks of servers. I think we're moving into a world with Internet of Things, and you have a highly distributed compute model, highly distributed data model. So the individual devices or some kind of a small aggregation layer can be a mini data center, if you will, because it provides a set of services to those downstream sensors and clients.
So we'll go back to having computers under everybody's desks again.
In a
serving
way.
the websites.
No, they just
No,
won't be under your desk.
No, you got it all wrong. It's the robots will be running around. They'll be the data center.
I just want someone to please write some really cool sci-fi novel where it's like, the horrible future where all the poor people are huddled around the data center for warmth, and so their phones work.
And then where are the rich?
Inside the data center.
They're inside the data center. So they are the data center.
You can call it the data center 1%.
Yeah.
No, they've transcended to a digital world.
Literally
we're going
in
way
the
off,
data center.
way off here now.
So data centers are really
I wanna read
medieval
this.
cathedrals.
So what are you going to call it? Back to the data center?
Maybe.
Oh, that was too bad.
That was pretty.
Oh, please. I think we need to stop right there.
1.21 petabytes.
So Duncan, you guys are dealing with how to think about systems, about distributed systems today. What are some of these kind of real complexities that you're just trying to get your head around now that relate to this conversation?
So I think, some of the work we've been doing with both IBM and with Basho is really looking at sort of both data and processing architectures in tandem, because I think if you do one without the other, then I think you're missing the point. So in fact, a data center is a misnomer, right? Whatever size, shape, form it takes, it's actually about managing if you like, the interleaving of the way in which data is distributed and managed in the sense of secured and so forth, and then how you're then going to interact and process with it. Now, I know that sounds like an oversimplification, but I think if you do one and not the other, I think you really are going to hit a problem. So what we, as a company, are trying to do is create control planes that help essentially specify the policies that will allow for where data should and shouldn't be and where processing should and shouldn't take place. That's independent of IoT, but IoT, and if you take that as being, as far as we know, the largest example of a distributed system, then I think a priori those rules or that way of thinking about the architecture has to apply.
So one of the things I'd like to explore for the next several minutes is to look at particular technologies that we're seeing emerge in this distributed systems context. So for example, schedulers and dynamic schedulers. Nick, can you talk to that, today's schedulers, and what are some of the things that are needing to be enhanced with today's schedulers that will kind of move us into like this thinking? Because, people are using smartphones all the time right now, so, the schedulers have to relate to that at least.
Well, there's two sides of it. I mean, you can go to schedulers themselves and say there's all kinds of first of all, there's several of them out there, but there's all kinds of new patterns that can emerge for scheduling better, right? And as more and more diverse workloads move to schedulers, as more and more enterprises and more orgs start to go that way, we'll start to look for the edge cases that maybe didn't show up before. The other part of it is the accessibility of scheduling. So if you look at the theory of it, most of what we have right now is truly based off what Google's done. And Google has been doing this, we know, for like 8 years, right? So this is not new for them. This isn't even a new technology in a way. It's new for us, or for me. And so there's a lot of things that have come out of this that are missing. So if you look at scheduling things that are out there right now, you look at enterprises, security, authentication, provisioning, automation. And scheduling itself is a form of automation. There's lots of things that are wrapped around. So if you look at like a VMware stack or an OpenStack, there's all these ancillary services that wrap around these things. And the transition from that to that plus automated scheduling and placement of all my workloads and the intelligence of microservices and code bases and development platforms and SDKs that are built to accept and do that. Because at Google, their whole workflow and application development and service development is based around the idea that you can write my app, build my app, and deploy it 7 times a day into my data center, right? And that's been the idea that we've wanted to try to achieve in CI/CD stuff. But I think with scheduling, we've got that missing piece to automate it over scale, and we just needed to start wrapping and converting these things we've had that have normally gone over to really strictly statically operational style stuff to actually match up to it really, really well and kind of get that holistic stack of I can develop and deploy and be very, very agile, but while still being secure and still having chargeback and still knowing who's done what and where.
So Donnie, you study the market and you see a lot of different. You have a pretty good knowledge of the varying technologies that are involved in distributed systems, and we're talking about orchestration systems in particular, right? And when you talk about schedulers, for example, what are some of your, what are your thinking about orchestration systems today and what they're lacking, right? Just right now.
It's a good question. And actually, I was talking to Nick about this last night, talking about how really everything that's happening right now with containers and with big data is just a rehash of what happened in HPC about 20 years ago.
Totally.
We're sort of rediscovering all the same lessons independently because nobody pays any attention to history. And so, back then we were talking about things like PBS and Torque and Maui and all these from a scheduling perspective, and now we're just redoing all of that, first with Hadoop and MapReduce and Yarn, and now we're doing the same thing in container land, right? Although, the big difference, I think, is, bringing in that cloud aspect, and I hate to hand wave around cloud, but it really is changing the way people build these administrative systems because you have to move from a world where you sit there with like configuration files to a world where you're thinking much more about system registry and service registry, just because everything is so transient dynamic that you can't possibly, especially with containers where, New Relic came out with that study this summer saying like 47% of the containers they see have a lifetime of like 2 minutes or less.
Right.
You can't add that to a config file and then take it out when it's gone anymore. So I think that's one of the big gaps that's been starting to get filled in. But at the same time, some of the things that like HPC systems have in terms of scheduling are much better understanding of the different types of resources in a heterogeneous systems. Even at large clusters, you would typically buy like different generations of systems over time and add to them, unless you're Los Alamos or something. And so, really understanding job placement in a heterogeneous system is, something that's missing from a lot of what's happening in container scheduling right now, and something that we're going to have to add as we move toward this IoT world, where you're going to have jobs that are distributed on all kinds of devices, all kinds of pipes, and you'll have to actually be able to sort of do self-healing and self-feedback on demand as connections get better or worse, as, systems decay over time, all these things.
Matt?
Yeah, so it's interesting, so Donnie was talking about the HPC. We actually spoke at cloud conferences, and I swear it was the same conference I went to like 6 years ago with Grid. The same people, the same charts. It was pretty funny. But the thing that's different, I think, if you look at like what happened with the grid, you had the application and the services that were kind of more tightly integrated to the OS, and you had a wide variety of OS, so it made it very difficult to move things around. So one of the things that people, breaking down service into microservices, making them such that they're autonomous services that are more easily consumed, it's the mobility of those services, the ability to move this microservice from this location to this location, and the barrier to do that is so much smaller than it ever has been before. It really opens up a whole new way of you looking at how you can architect solutions and applications. Now, for example, because of things like the cloud, I'm not bound by just the capacity of my data center. I can tap into the infinite capacity of the cloud. Because I have Linux as kind of being the standard level of OS, now I can run these containers anywhere there's a Linux. And so it's becoming so prevalent that it's opened up my aperture so I can do a lot more things in a lot more places, which then has the side effect of causing to expose some of the gaps that didn't exist in the HPC land as it relates to scheduling. And that's why you see Mesos and others, looking at closing those gaps.
Totally. I mean, the other part I would add to that was awesome. Both of those were pretty awesome statements. The other thing I would add is you kind of hinted at it a bit, Donnie. When you have the ability to put anything anywhere and you're dealing with failure and if your state is well managed in a way where you can recover it, I think the interesting part is going to be the network piece. I feel like, and not in the classic manner about like latency or bandwidth. I think it's actually the intelligent part. And that knowing where things flow, it's kind of, in my mind, I picture it as like, a series of pipes. So for example, you pour the water at the target. So feasibly, your microservices could be everywhere, right? And you just, implicitly, because I don't have to configure them all, I can literally have any one of my services anywhere it could go. And so the flow of the requests and the flow of the traffic is so much more important because I could basically point it over here. If things are going wrong here, I can just point it over here, right? And so I think the flow of network and the intelligence of that layer is, unless the bandwidth necessarily, but the intelligence of that layer is going to be way more critical.
So the container density issue is often cited as an example, right? Mm-hmm. And how you solve this. We're still trying to struggle with how you manage container density in a network.
Totally. And if you look at some of the biggest container running people in the world, most of them have very, very powerful distributed storage systems and distributed replication systems in place to handle that. And that's one part of it, is the ability to be able to put something somewhere, move it, or place it, or pull the resources from it, right? Or the resources it needs to run. But the other one is just a general flow of traffic. It's like the flashlight in a dark room, right? So feasibly I can shine the light anywhere in the room, but where I point the traffic is where I light up. And so that's my idea, and that's a really poor idea of it. But the idea is that if the things are lightweight enough and small enough, and things are distributed enough because distributed systems, then the flow of the request is much more important that you can dictate where it goes.
So it's an autonomous almost thing. You could say, like, where the light flows and that turns on.
If you start detecting failure, you can really just, because anything can be anywhere.
The robot launches.
Yeah, feasibly, most things can be most places, versus very vertical, like the app is here, it's in Boston, and the apps is here, it's over here. It's like, no, the app's actually broke up into many components, and depending on which component at which point in time suffering, I can reflow those requests and redirect.
It's almost like you could route those requests, and you could have something that could route the traffic from one place to another.
But our current routers are middlemen, right? The intelligence has got to be way higher than that.
It goes back to that feedback loop you were talking about. The existing routing protocols, the way it works, is you assume that you have a steady state and a static environment, and you're trying to optimize that static environment.
That's right.
Especially with IoT, you have a living, breathing organism from the device all the way to the back-end system. And just like our bodies change, the living organism changes. And so you had to be able to adapt to that. So being able to reroute based off of that feedback. So one of the things that's really missing today is there's these pockets of information. They're isolated, they're siloed, and there's really not a good way of connecting those together into an intelligent system. Now, one of the things that was stopping that in the past was people, when they delivered services, they delivered them on schedules, and you had a steady state and you didn't want to change. Well, with the mobile phones in particular, people, instead of avoiding maintenance and avoiding new functions, they are looking for new functions, all right? So this continuous delivery, continuous operation gives us a real opportunity to change that model such that we can adapt to the changing world around us and make things better. And that's what I think you see a lot of colleges, universities that we work with a lot. The students that are in the college and university, they really feel like they can make a difference in their world because they know of the impact that they can make.
Duncan?
So I would make a couple of observations. First of all, we're talking about a very big canvas. So if you're just trying to sort of, if you're a photorealist and you're trying to sort of just exactly paint one piece of that canvas, you're not going to create a real picture, right?
Could you define photorealist for us, please?
Sure. A photorealist, an artist who produces a work of art that's better than a photo. So, and I guess in 4K that would be, pretty impressive. But, or it's like the guy in Hitchhiker's Guide to the Galaxy he's just doing the fjords, I mean, great. I'm glad somebody's doing the fjords, but we want to think about the bigger picture. And for that to work, yes, you have bottom up, you have faster, smarter, leaner, meaner sort of infrastructure to run on, which means you can push things further out into the network. But equally, top down, if we all worry about everything, it's pathological. Therefore, I want to be able to, as a developer, specify some intent, what I'd like to see happen. But God forbid I tell you, the next layer down, how to actually enact that, because that is that is breaking the abstraction.
By the way, I'm gonna use, from now on, I'm using that as like a diss for somebody who's like too myopic. I'm gonna be like, oh, he's just worried about the fjords.
No, he's just a photorealist.
Yeah, he's just worried about the fjords.
I think there's a problem, though.
I hate to say that word, right?
I think there's a problem. All of the existing networks, the routers and everything else, are all designed based on the idea of humans being involved in the feedback loop.
Yeah.
Humans doing the provisioning. We all, well, not all of us, but most of us still live in the IPv4 world because IPv6 is, you can't remember an IPv6 address, at least I can't, maybe somebody can. Not only are there no feedback loops, but
Well, I hear people say that's the biggest issue, for instance, with container density, is like everyone's still on IPv4.
right, but that's the problem. The problem is that the networking system, the entire set of rules that we have around the way we run network infrastructure and equipment, DNS is another example, all of those things are all rooted in a world that doesn't conceive of these flows that Nick was describing. And what really needs to exist is a router that's based entirely on these feedback loops and some rules. The rules are more sound rules. I'm not talking about human beings typing in a bunch of specific rules and every day trying to add and remove rules, but more of a system that is doing all of these intelligent things to facilitate communications, for it to recognize that this is a bad actor and to cut that bad actor off.
What's interesting about that is that's actually, the OpenFlow design is based, not necessarily on accomplishing that, but it's towards that direction.
Yes.
And that the switches are dumb as heck.
That's right.
And they make no decisions, and then you have some kind of controller up top that decides for them as decoupled.
Yes.
And feasibly, you could extend that to be smarter about the application flows.
What was the company that Docker bought?
Which one?
Socket plane?
Socket
Yeah,
plane.
Socket Plane.
Well, Socket Plane's awesome. They're
Yeah.
brilliant set of people.
They had some different ideas about that, didn't they? They were talking about not just this one brain. They were talking about like this idea that in society there's multiple brains that need to work together, right?
Yeah, and Weave is another example of trying to solve that, but I don't think, they're solving it in software, and I think you need the network infrastructure vendors to be much more deeply involved as well.
I guess my question then becomes, and I've been thinking about this as you guys have been talking, is so we have AWS over here, and so like let's say you're any startup in the room, and you're, a lot of them are using AWS, right? But there's Google Compute Engine over here, right? There's there's SoftLayer over here, right? Those are the silos, aren't they? I mean, those are the ways that are preventing us from having kind of a much more of a unified infrastructure, aren't we?
It's partially that, but I think it's partially like the carrier networks.
That's exactly.
I mean, because you're moving from thinking about compute contention on a single node to network contention, and we're going to have to be sharing a lot more of that data back and forth, so that once you even have these adaptive systems locally, they have the data that they to use to adapt in the right way.
Right, and we're talking about no longer just simple things. Now we're moving to, and not only like an ARP cache on a local router switch, but the way BGP is structured and how BGP sharing and peering points are working, and all of the derivatives of that, all of that needs to fundamentally change in order for you to hit that global scale the way everybody would really like it to.
We only have a few minutes left, and so I do want to see if anyone does have any questions. If not, we'll go back to the conversation here. But does anyone have a question for the panelists right now?
Is anybody awake?
Anybody?
Is there anybody out there?
Is that a question right there? No.
The pancake
Is that a question over there?
Scratching.
Okay. Okay, back to pancakes. So,
They're all cardboard cutouts.
so Donnie, what were you gonna mention something? I'm sorry. Were you, or were you not?
No, I was just thinking that everybody's had all the carbs from the pancakes. So you're
Yeah,
kind
they're
of
all
sitting
falling
back, like
asleep.
enjoying it.
Well, we only have a few minutes left, and so maybe we can talk a little bit more about maybe this feature that you would like to see out of distributed systems. Like, what would be your, you're working at Intel, and like you guys have your own visions of like the technology itself. But Nick Weaver, what is it that you see today that you would like to fix right now so you can get to that
We have
place?
questions.
Oh, there's a question? All right, great.
Actually, going to your point on the data centers that you guys were talking about, one interesting thing that I see is data center size. When I got into the industry 20 years ago, a data center could be a room in a university, and that could still be a really difficult operational management nightmare. Nowadays, at the scale that I see data centers, they're multi-acre buildings, and even that's considered a small data center usually, and the purchasing power just isn't there. Now, you've got Google who, an idea of a data center is something that's the size of a town that I grew up in and went to high school in. It's interesting with the Internet of Things, we talk about all of these devices coming in and the computing there, but then when we see the actual large-scale computation that we're still bound to in the data center to process all this data becoming just orders of magnitude bigger, how do you think this is going to drive the industry? Because now you're left with Google or the compute vendors themselves being the folks who can operate the data centers effectively and at reasonable cost.
I think fundamentally how we do some of these things is going to change. I think you're going to see, we had for a long time first we had mainframes, we watched that evolve to minis and micros and then to PCs and client server architecture, yay, we're all doing things under our desk. And then we've kind of moved to cloud where people are now doing things kind of centralized again. I think the real answer is...
Now we're talking about mainframes.
Well, kind of, but what I think...
But distributed mainframes,
I
obviously.
think what's going to happen is, I think the answer is yes. You're going to have mainframes, but you're also going to have distributed compute and client server, and you're going to have them all at the same time. And the real answer is, depending on what you're trying to accomplish, decides where the processing happens, where you're going to send your data, how you're going to send it, and where you're going to store your data. And I think depending on what you're trying to do decides what the optimal place for you to do those things are.
Yeah.
In IoT, it might be that some of the processing needs to happen all the way out at the farm or on the airplane or in the car or something like that. And you want real-time processing and you want that feedback loop as tight as you possibly can get it, which means physically there in that proximity.
Yeah.
At the same time, you might want to batch up some of that data and you might want to send it to a centralized source up in the cloud where it can aggregate and look at the overall big picture of what's happening.
Right,
Yeah.
that makes sense.
Yeah.
Because we talk about hybrid today in terms of hybrid cloud, and we typically talk about a customer's data center and then the cloud provider. In my opinion, with IoT, there's a completely new type of hybrid, and that hybrid is some kind of edge compute, whether it's on the device, some kind of aggregation layer, but this hybrid of, to what Dave was saying, is some autonomous system that can do something on its own, completely independently of a back-end system, but then when it gets access to a back-end system, it can provide that value back to the back-end. Then the back-end can do additional processing and then provide insight back to the edge, so the edge can then do some kind of control optimization. So this goes back to this living, breathing organism again that I was talking about, where each individual part plays a role, but this, the sum of the parts make up the whole, living organism.
Right, and I want to make that a little more concrete because I think it's always nice to, panels are easy to wave your hands around on, right? So there's actually a company out there doing something like this right now. It's called SK Solutions, and they manage the biggest construction site in the world. It's in Saudi Arabia somewhere. They have like 300 cranes, all kinds of trucks and everything. And all of them are instrumented. Every single person, every single thing on that site is instrumented and is autonomous. And what they're doing is calculating risk live on site.
Are you sure
And
that people are autonomous?
And if the risk gets too high, it will actually take control of a truck or a crane and make it stop, make it speed up, move it away, whatever. But then it sends things back home to improve the risk model, right? To do the big number crunching at home.
Duncan?
So, I mean, hybrid is a term that we do throw around, but I mean, I think, and I'm not being funny here, hyper hybrid is really what you're saying, where it's
Hyper
not-
hybrid.
it's not-
Object reality and hyper hybrid.
I think
All
so,
right.
because it is about what you're trying to achieve, where you want to achieve it, and absolutely. I mean, and by the way, that won't scale. I'm sure that if you try and do a construction site globally like that, it won't work unless you then segment it. So I mean, ultimately, this notion of segmentation, tiering, whatever way in which you want, whatever word you want to use, it is about thinking about the specific scenario. I mean, even an enterprise, which we kind of go, enterprise, easy, done that. Enterprises, when faced with a barrage of vendors telling them what they should run on, actually, generally speaking, push back and say, no, I'm going to run on probably at least 3 of those target environments because it's going to depend on what I'm trying to achieve. In which case, you better make sure they interconnect. So I'm not going to go just with Cloud Foundry. I'm not just going to go with Mesos or whatever is the latest flavor of the month. I need you to provide me with a way of actually interlocking those.
So we're talking about automation. We're talking about, these fabrics, so to speak, and the changing, you talked about the changing kind of heterogeneous nature of, going from mainframes to where we are now. Are we entering this age of like DIY data centers then? It's like we actually you can just spin up your own data center, so to speak, that you can have and just run what you need to have run?
I think it depends on what you call a data center.
Yeah.
Data centers are
DIY
being built like
resource?
crazy now. I actually think that, if you look at like Facebook has a huge data center in Oregon, and just next to us at Intel in Hillsboro, there's like 4 data centers being built right now, and there's like 5 of them already. And in Dallas, where I'm from, there's a data center capital of the world. There's data centers. You can throw a Rocky at a data center. I actually think that the more demand for it actually commoditizes the cost a bit, and it makes it easier to build. And there's a whole ecosystem of people who are not even worried about colo as much as like, I just want to build a data center, and companies will come in and buy whole rooms because they don't want to be in the business. So I think data centers are still going to spring up. I think they may get to be smaller, like even more efficient. But I don't think we're getting away from it. I love the idea, by the way, of like humanity being based around the data center. Because if you think about like the old days, humanity was based around the river so that the wheel would catch the water, and then if humanity was based around the coal plants to get power. It's like our future, like we're based around with compute is centralized.
The problem is all the data centers are moving up north, and so we're going to be cold again, right?
Well, I moved up north for the same reason.
You're going to be huddled around the fire in Sweden.
But there's a
We'll let Dave finish, then we got to go.
humanity though also flourished as you had centers of information. So if you think of the Library of Alexandria, you think about all of those things, your access to the information actually made you more advantaged. And I think that still will hold true. And those who have better access to the information are more advantaged than those that don't. So if you're closer to or have better access to the information, you're advantaged. Not just the examples you gave were all power. Power, electricity is valuable, but so is the information.
So on that note, I think we're going to have to get going.
I'm just saying, my YouTube video loads faster, so I'm smarter, right?
Yeah.
Could be.
So on that note, on data and humanity and the future of our civilization, thank you very much for being here for the panel. Thank you all.